All right, so 63, section 8.2 in the Finney textbook here. This is a tricky limit question, one you probably haven't seen before. You're not going to see this too much here in this course, but I thought I'd go over this one because it's interesting. To find the derivative of this, now remember L'Hopital's rule says that if we have a rational function like f of x over g of x, a rational situation, and it turns out to be an indeterminate form when you simply plug in your value that the limit is approaching. If it's indeterminate, 0 over 0, infinity over infinity, so on, then you can apply L'Hopital's rule and take the derivative of the top and derivative of the bottom, then plug the value in again and see if something changes. And you can keep doing that. But we don't really have that situation where we have f of x divided by g of x. Also, if we're thinking about plugging values in for x, you certainly could find the limit, this limit here, because all you have to do is just plug in values that are really close to 0 on the positive side. Okay? Now, I'm assuming that you do not have access to a graphing calculator with this one, or you could just graph it and see what the function, y equals x to the power of x looks like. It's going to be something pretty crazy, but we don't have that ability. But what you want to do is you want to think, okay, I'm going to try some values close to 0, and I'm going to see what those values give me. So for example, 0.1 to the power of 0.1. Okay, that's actually 1 over 10 to the power of 1 over 10, or the 10th root of 1 over 10. Now remember, when you have a fraction and you take the square root, okay, the actual value is greater than that fraction if it's between 0 and 1, okay? So the square root of 0.5 is about 0.7, right, and so on. So it's a little bit larger. So if you have a really small one and you're taking the 10th root, it's like, what number are you multiplying by itself 10 times to get 1/10? So you think that's got to be a number that's greater than 1/10. It can't be greater than what number, though? So this number is small, but it can't be greater than what? It can't be greater than 1. That's true. 1 is correct. So here's 1/10. If I start somewhere around here and I multiply by 1/10, and then by 1/10 again, then by 1/10, if I do this 10 times, I'm going to get to my value here, right? So this is the 10th root here, okay? Now, if it's 1, the 10th root of 1 is 1. And if it's anything greater than 1, then we're going to get smaller. Actually, I kind of went the wrong way there, didn't I? Oh, no, I went the right way. So what about if I do this? What about the 100th root of 1 over 100? Well, that number also has to be greater than 1 over 100. And we're going to have to take the 100th root, like the sort of the square root 100 times. Think about it like that. So this number, if it's really small here, this number is going to have to be really large comparably, but it can't be greater than 1. So if you do 1,000 and this, so whatever you can do in your calculator, right, you would get, if you tried 1/10, 1/100th, 1/1000th, things like that, you're going to get like 0.92, 0.97, 0.99, and you're going to see that it's going to get closer and closer and closer to 1. So just by testing some values, you're probably going to guess that this limit equals 1. But how do you justify? Okay, so we're not really proving. It doesn't say prove, but justify. If you just did a list of examples and said, by the patterns that I'm seeing here, the limit is 1, well, you'd probably get the answer right. But is that enough for a proof or a real justification? So this is in the L'Hopital's rule section. So there should be something we could do for L'Hopital's rule. And I'll show you this. This is one of the things that you can do. And this is a bit of a stretch, I would say, from the basic sort of types of problems that you have to look at. But let's just say we focus on x to the power of x. I want to focus on that, okay? Now, this is not a power rule situation. You can't drop the x down and say, I'm going to just drop the x down and then I'm going to do this, x minus 1. No, you can't do that. That's only for polynomials where this is actually a number of some sort, okay? So if it's got a variable in the exponent position, that's different. You can't do sort of the power rule to take the derivative. But how can I rewrite this where there's some sort of fraction involved, okay? Because remember, L'Hopital's rule works if you have some kind of ratio of functions. So this is the step. Now watch carefully, and you wouldn't think of this probably, but how can you rewrite x so that we have that's in a different form, either that's a fraction or that we're writing another exponent. And the hint is we want to write this as a power, okay? So how can you write x as a power? So with some base to some power. Any ideas? Anybody remember what we've been learning in this course fairly recently? E is my hint for you. How can I rewrite x using E? What do I put up here? Who remembers? X is equal to E to the power of what? Ln what? Ln x. Very good. Okay. E to the power of ln x. Now, that is strange, I know, but remember, this is one of those, it's a rule, right? It's a rule that we learned. So you can rewrite anything as e to the ln of that thing. So like 5 is e to the ln of 5, because the e and the to the power of ln kind of like outdo each other. They undo each other. So you just have 5, okay? So this is true. Now, I have x equals e to the ln x, but this whole power is actually e to the ln x to the power of x, like this, okay? And what do you do to exponents when you have a power raised to a power? What do you do? Do you add them? Do you subtract them? Multiply them? Divide them? What do you do? You multiply. Very good. Okay, so I have x times ln x. Okay, so is everyone okay with what I've done here? This x to the power of x, I've simply rewritten this as this. Are we okay with that? Now, taking the derivative of this is going to be okay. Now, you could take the derivative of this, and if you had to take the derivative of this is how you would do it. So dx, don't write this down, because this is not the question. But if you had to take the derivative of x to the power of x, this is exactly how you would do it. The derivative would be e to the x ln x times, right, the derivative of this, which is a product rule now. This is just simply product. Derivative of the first times the second plus the first times the derivative of the second. So that's your derivative. We'll simplify this to just 1. But that's not what we're asking for in this question. We're asking for this limit. So how do we use L'Hopital's rule here? Well, watch this. And this is where it kind of is a little strange, I'll admit. But I'm going to write this right here as a fraction. Now, how do I write this as a fraction or a ratio of functions? How can I write this? Anybody, any ideas? Again, this is, I know this is not intuitive. This is not generally just like, oh yeah, I know 5 plus 3 is 8. That's easy. This is, you don't look at this and what you have to do, and this is the interesting thing about calculus, guys, okay? When you learn all of these special portals, special little paths in the forest, you can actually use one of these special little paths that you've learned about, and you can go places that you would not normally intuitively go. And that's exactly what we want to do here. So again, L'Hopital's rule, ratio of functions, that's when I can use L'Hopital's rule to find some kind of limit. Watch this. And this is crazy, I know. Ln of x over 1 over x. I know. Why would you do that? I know. I get it. It's strange. But x, you see, is the same as 1 over x, right? That's what that is. It's the same as that. So you can do that. Now you have a fraction, okay? And this is why this one is challenging. And it even took me a while when I was thinking about this, how I was going to do this question. It even took me a while to kind of wrap my brain around, okay, I'm going to do L'Hopital's rule now with just this ratio right here and leave e alone. Well, what do you mean? Don't you have to do L'Hopital's rule to the whole rational function? Well, if you just focus on this, you're going to leave that e out there. But I want to know, because there's no x here. See, there's no x. It's not xe. It's not, e does not have x in it. So e is not affected by how x moves. So I have now got a fraction or a ratio of functions that involve x. So L'Hopital's rule applies. So I'm just going to leave the e hanging there. And what I'm going to do is I'm going to take the derivative of the top. So I'm going to do d dx of this now. What's the derivative of ln of x, guys? It's 1 over x. 1 over x to the negative 1. What's the derivative of 1 over x squared? Or 1 over x? Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. What's that? Negative 1 over x squared. Okay? So this is negative 1 over x squared. Okay. Now I simplify this by flipping and multiplying. So I've got 1 over x times negative x squared over 1, which is e to the negative x, which is e to the negative x. Does that simplify to that, guys? You good with that? E to the negative x. Now, as x approaches 0 from the right, can I now substitute in this or not? Can I substitute something in here? Right? Because now we've got what? As x approaches 0 from the right. Okay? Well, maybe it might be, and you could plug your calculator in, or plug this in your calculator, but what is e to the, whoops, whoa, what's going on? What's e to the, well, e to the x. E to the x looks like this, right? That's e to the x. So what does e to the negative x look like? Just think back to pre-cal 30. What does e to the negative x look like? Come on, nobody? Come on. Anybody? Does it flip this way, up and down, or does it flip sideways? It's one of the two. That's your hint. What is it? Okay. If we have negative e to the x, that's a negative on all of the, what would be the y values. So that's a flip vertically. This, when the x itself is negative, that's a flip horizontally. So it goes like this. Okay. Now, if you got it wrong and you flipped it, if you flipped it this way from the e to the x, that is a problem. You get the wrong answer. But here, as x now approaches 0 from the right, what does this function value approach? What value is that? It is yeah, 1. 1. Right? Okay. E to the x, right? Y equals e to the x. This is always 1 here. Okay, that's always crosses 1. Why? Because e to the 0 is 1. So what's e to the 0? 1. So, all in all, I'm going to wrap this question up here now. It's been a marathon here. This right here is equal to this. The limit as x approaches 0 from the right of e to the negative x. Same thing. So if you plug 0 in there and know that's a continuous function, we have e to the 0, which is 1. Okay? The tricky part, the really tricky part is getting this to this, right? By use of some kind of fancy manipulation there, using e to the ln x, and then using L'Hopital's rule, okay, with your x ratios. All right, so that is that question. Tricky. That is a very tricky question there. L'Hopital's rule can be applied there.